All right, so before we actually start to do these examples, because now we're going full into the geometric proofs, I want to go over these properties on the back. So these are 3 important properties. These are used very often in a geometric proof, but it's not something necessarily that you use so much in algebra. So the reflexive property is, say, something like AB equals AB. Well, some people are like, well, that's dumb, I know that. But it's going to be very important in terms of using some of the other properties that we have to go over. So anytime you're saying something is equal to itself, that's the reflexive property. In terms of symmetry, think of like a mirror. It's a reflection back at you. So with symmetry, we're flipping things. So if AB equals CD, then CD equals AB. All we're doing is we're flipping the order. Now, transitive is a little more difficult. So transitive, you have 2 congruent statements, and the answer gives you a congruent statement. Okay, so if AB is equal to CD or congruent to CD, and CD is congruent to EF, note both of them have a direct connection to CD, so that is the common link between both of those statements. Therefore, what we can link then is the other 2 together, saying that AB is equal to EF. So that's one that's going to take a little time. I will show you for sure in these examples how that comes into play, but I just wanted to make sure that we go over these properties first. All right, so let's go. Example or sample number 1. So I've already have the setup for you, statements and reasons. So we already know what our first statement has to be, so let's all just copy it down. So CE is congruent to FE, and we know that ED is congruent to EG. And again, without even thinking, we know that our first reason has to be given. Now, something new that is going to come up is going to be the statement that we see right above this sample. So it says if A, B, and C are collinear, then B is between A and C. If and only if we take the 2 smaller segments, AB, and we add it to BC, those are going to equal the larger segment. So we've done this in terms of algebra in chapter 1, where we were adding numbers together or subtracting numbers to find the missing parts, but we're going to start to do it now from a geometric side. So we have our given written down. We have congruent marks or congruent statements. So what we're going to do is we're going to mark stuff. So it says CE, here's CE, is congruent to FE. So I'm going to give them the same notation. We also know that ED and EG are congruent, so I'm going to give them a different notation because those 2 are equal to each other. So our goal is to then show that CD, which is one of the larger segments, is equal to FG, which is the other larger segment. So I'm going to use something called, again, I'm going to do this one first because this is new to you. I'm going to use something called segment addition. And segment addition is just that. I'm adding segments. So if I look, the bigger segment is CD. So CD is made up of CE plus ED. This is what we did for the algebraic problems. For the other one, FG is equal to FE plus EG. So all I'm doing is writing a statement where I'm showing that the 2 segments are being added together. Now, I have to show that they're equal to each other. Okay, and again, you're justifying your reasoning, so it's not just, oh, they have the same marks. So what I'm going to do is I'm going to take my statement for CD and I'm going to rewrite it. So if we look at CD, if I look here, CD has CE in it. Well, where else do I see CE? Right here. Well, CE equals FE. So instead of writing CE, I'm going to write FE. For the other one, ED, where else do I see that? Well, I see that right here. And what else is ED equal to? Well, it's equal to EG. So I'm going to replace them with what they are equal to. So think, when you are replacing, anytime you are replacing, what is that called? That is your substitution property. Okay, and then number 4, now what we're going to do, so this is where one of the new properties are going to come into play. So if we now look at our 2 previous statements, and I know I'm drawing a lot with colors here, but I'm just trying to make connections here. If we look at these 2 statements right here, we say, okay, well, what do they have in common? Well, if you look, both of them have the same thing on the right side of the equation. And if we learned on the back side of the property, if you have 2 things, this one right here, if you have something equal to something, and something else equal to that same something, then you can set the two of them equal to each other. So if both FG equals FE plus EG and CD equals FE plus EG, then I can set FG and CD equal to each other. So FD is equal to CD. And that is our new property for transitive. Okay, so you can either use equals, congruence. I'm just going to modify it in the last line here. Now the reason I have to add an extra line is because if you look at your proof statement, I don't have that written here in the right order. So they're not in the same order. So I have to flip it. So I'm going to write CD is now congruent to FG. So I'm just going to use them interchangeably in terms of congruence and equals, and that's fine. Let me just add all these segment symbols on here. All right, so if I'm flipping something, again, think back to the properties. If I'm flipping, that would be symmetry right here, which is property number 2. So that's going to go right here. So this is the symmetric property. All right, so these are definitely challenging. I'll tell you that I'm going to start you off with filling the blanks in instead of just doing them randomly by yourself. But at some point, you are going to have to replicate it and come back and do it on your own. Okay, it is going to be blank. You will have a word bank to work with. But again, it is going to take a little bit of time just because this is a brand new concept to many. All right, so let's see here. Let's try another one. So we know what our statement, our first statement is, and we know our first reason is given. And if I mark, I know that JL and KM are congruent to each other. So I have to add a little extra piece there just so I can show that the whole thing is equal. All right, so my goal is now I'm going from JL to JK and from KM to LM. So I'm getting smaller. So most likely I'm not going to necessarily be using properties that might add to something. What we are going to do is what you're going to find is if you look at those two segments though, the two segments in blue with the little mark on it, you ask yourself, well, what do they share? What do they have in common? Well, if you look here, they both have KL. So again, back to the back side of the note sheet. When you have something that is congruent to itself, that is the first property, which is the reflexive property. So anytime you have an overlap of sorts, and this is a perfect example for that, you are going to use the reflexive property where you have to state that it's congruent to itself. Okay, now some people might say, well, that's kind of dumb, but again, this only would apply in a geometric sense in terms of when you are doing two-column proofs. All right, so here we go, line 3. So again, I'm not really getting any closer. So let's do something that we did in number 1. Let's use like segment addition maybe. So the full segment JL equals JK plus KL. The other one, KM, is equal to KL plus LM. So same idea that we did for example number 1 in terms of adding the two smaller parts for that. All right, so let's see here. So next thing we are going to do is if you look at statement number 1 and you look at statement number 3, JL is congruent to KM. In statement 3, we said that JL equals JK plus KL. So what we can do then is because you have those two statements that are equal to the same thing, JL, that's the connection. Again, I'm flipping back and forth here. The transitive property says that if you have the same thing that's equal to the same item, then you can set them equal to each other. So what I'm going to do is, it says JL is congruent to KM and JL is equal to JK plus KL. So I'm going to now say that KM equals JK plus KL. So I'm replacing it, but these are congruent statements, so this is your transitive property. Now for step 5, if you look at these two guys, what do you notice? Well, they're both equal to the same thing. Well, if they're both equal to KM, again, I'm repeating what we just did for the last step. I can set those two larger statements equal to each other. I'm going to take the KM out of there. Again, that's the direct connection using the transitive property, and I'm going to take the other two parts and set them equal. So this is another transitive situation. Many times you are going to use the same properties over again, so don't necessarily think you're doing it wrong. Now for line 6, we're trying to prove that JK and LM are congruent. Well, if we look at our last line that we just wrote, here's LM and here's JK. What do the two statements, both the left side and the right side, have in common? Well, they have a KL, so let's get rid of it. So if it's being added, then what we're going to do is we're going to subtract it. So we're going to use subtraction to get rid of the KL, and we're left with LM is equal to JK. So again, it gets rid of it on both sides. And now the only thing we have to check for is here's our proof statement. Again, not written in the right order, so we're going to flip it, and I'm going to add in the congruent marks, so when